Good morning, guys. Today, inshallah, we're going to start in section 30 of chapter 5. We're going to talk about the electron configuration and the periodic properties, which means we're going to study how the properties graduate within the periodic table, depends on the atomic number or depends on the electron configuration of an element. So we have some properties, we're going to study them and how they are, or how we could predict the properties of some elements regarding to their place in the periodic table. So in the last section, we already know how to locate an element in the periodic table, and we could predict what the type of element it's metal, non-metal, or metalloid regarding to its position in the periodic table. Today, inshallah, we're gonna learn how to know some physical properties or some chemical properties regarding to the positions. First, the property we're going to talk about is the atomic radii, or actually the atomic size. So because atom somehow it's look like a sphere, okay, so we could use the radius as a representation for the size of the atom. So the atomic radii, it means or represent the size of the atom. So we ask what is the radius? Of course, we're gonna have the radius of the mass, the distance between the center of the circle to the outer line. So here also the same, the atomic radius, it is the distance between the nucleus to the outermost energy level of the atom. But because the outermost or the energy levels, they are not somehow solid or they are not constant, they could change, it depends on the different conditions. That's mean, for example, in high temperature, again, they are expanding, and in cold temperature, they will contract. So this distance is not that constant. So if we need to compare between two atoms, or if we need to compare the size of the two atoms, okay, we should compare these two atoms at the same conditions, because in different conditions, this comparison will not be true because the radius will differ. So here we said that to compare different atomic radii, they must be measured under this specific condition or certain conditions. So how we could measure the atomic radius, because as we said, it's hard to find distance to the outermost energy level. So we have another way to find the radius. We said that radius, it is half distance between two nuclei of identical atom when they are bonded together. So that's mean when so we have two atoms which are exactly the same, they are bonded. I'm gonna measure the distance between the two nuclei of these two atoms, then divided by two because they are two identical atoms. So it means they have the same radius. So we're going to divide the distance between the two nuclei by 2. So like this, we get the radius of one atom. So here like this, we know what is atomic radii. Then we ask how this size of atom is graduated within the periodic table. So by logic here in groups, so we are going to find that in groups, as we move down, of course, the size of the atom will increase or the atomic radii increase, because we know that each period represent a new energy level, or means we add more sub energy levels. So as we move down, of course, we add more sub energy levels. So like this, we are gonna have a larger atom. So in any group, as we move down, the atomic size or the atomic radii increases. While in periods, once we move across the periodic table from one side to another, from left to right, we're gonna find that they start to, or the size start to decrease or decreases. Why it decreases? Because as we move across the period, the atomic number increases, which means the number of protons inside the nucleus increases. So as the number of protons increases, it means more attraction force between the positive nucleus and the outermost and the electrons. So like this, we find that size start to shrink or start to decrease as we move across the period. So here we said that they trend to smaller atoms across the period caused by their increasing of the positive charge, the atomic number, the number of protons inside the nucleus, which attract electrons toward the nucleus. Atoms tend to be larger further as we move in group, because as we move in group, we need that we add more sub-energy levels. So here, as we can see here, guys, we could easily observe that the atomic size increases as we move down in group, while it decreases while we are moving across the period. Okay. So here then we said that, for example, I give you one of the elements: magnesium, chlorine, sodium, and phosphorus. Which one has larger radius and which one? So let's try to answer this question together. Let's mix two sections, okay? So we're gonna use what we learned in the last section here. He gave you already three elements: sodium, Na11, and he also said chlorine, that's 17, magnesium 12, and phosphorus, which is 15. So that's the different atomic number of the sun. So let's make the kind of electron configuration for each one of them. So once we start to make that, it's 1s2, 2s2, 2b6, okay, then 3s1. While here 17, 1s2, 2s2, 2b6, 3s2, 3b5, 5, okay? And then here we're gonna find magnesium 1s2, 2s2, 2b6, 3s2, while phosphorus 1s2, 2s2, 2b6, 3s2, 3b3. So like this we have it. Let's start to locate each one. So as here the highest energy level is 3, so we're gonna find it's the in period 3. So this one in period 3 and the group 1 of course of the S block. Okay, so here why the other one here, the second element, we're gonna find the second element it found also in period 3 because that's the highest number, the highest n. Okay, while we are gonna find in group 7 because here the outermost energy level, okay, it has two sub energy levels S and P, and they contain 7 electrons, so they are found in group 17. Okay, so we said that that's plus 10, so they are in group 17 or group 7A. Then magnesium we are gonna find also found in period 3 and it has in group 2. Okay, while phosphorus it's in period 3 and it's found in group 15. Okay, so plus 10. Okay, because here we find in the P block. So like this, we know the application. So we're gonna find all of them. They are found in the same period but different groups. So once we try to arrange them regarding to their group, we're gonna find sodiums first, then magnesium. Okay, then phosphorus, and finally we're gonna find we have chlorine. So regarding to this, okay, we're gonna find that the arrangement of the atoms. So as we know, as they are in the same period, so once we move like this, the atomic size will decrease. So we're gonna find the largest one is the sodium and the smallest one of them is the chlorine. So here, that's here how we could predict the atomic size of an atom in um, uh, how we could predict the atomic size of an atom in the periodic table. Okay, so then let's check our answer. We said sodium is the largest. Okay, so then pass to another thing which we call ionization energy. What is ionization energy? So let's recall some information we know what's meant by ion. Ion actually it's an atom that carry positive or negative charge. So how an atom could carry positive or negative charge? We know that atom is neutral because the number of positive protons inside the nucleus equal the number of negative electrons that rotate in energy levels. So that's in normal conditions, but actually once the atom goes through the chemical reaction, which means once it gain or lose some gain or release some energy, electrons could escape from the outermost energy level, or it may gain electron from other atoms. So in this case, the number of electrons will differ than the number of protons, so it may carry charge. So that's mean here, for example, the metals. We know that metals, they have just 1, 2, or 3 electrons in the outermost energy level, so they are easily to lose them during the chemical reaction. Once they lose electrons from the outermost energy level, we're gonna find that the number of electrons become less than the number of protons. So in this case, the atom will carry a positive charge and a positive ion. While, for example, non-metals, they have 5, 6, or 7 electrons in the outermost energy level. Like, for example, chlorine has 7 electrons. So it just need 1 electron more to make its outermost energy level completely filled and become like a noble gas. So in this case, it's easy to gain an electron, and in that case, we're gonna find the number of negative electrons will be more than the number of positive protons. And here, like this, it will be a negative ion. So ion is an atom or a group that one atoms that has a positive or negative charge. So for example, sodium easily lose an electron and turn to be positive sodium positive 1 because sodium is 11. So the outermost energy level, the sub energy level 3 is contain 1 electron easily to be lost, and in this case it will be positive ion. So the question here, how an atom could lose an electron? Simply, atom could lose an electron, okay, if it gained enough energy that could overcome the energy of attraction between the positive protons inside the nucleus and that electron. So the outermost electrons, they are easily lost in metals because the connection between this electron and the nucleus somehow is not that strong. So sufficient amount of energy is enough to release this amount of energy, which is needed to make the ionization process or to release this electron or to make 1 electron lost or more from the atom. We call this the ionization energy. So the energy required to move 1 electron from the neutral atom, we call this ionization energy, or we give it abbreviation IE. So here that's we call the ionization energy. So what do you think about the graduation of ionization energy in the periodic table? So here actually somehow it's related to the atomic size or the atomic radius, which means as we move in group down, of course, the size of the atom become bigger, as we said, because we add more sub-energy levels, which means that the distance between the nucleus and the outermost electron will be longer. So the attraction force, of course, will be weaker. So we don't require this much energy to release that electron. So that means as we move down in the group, the ionization energy decreases because there is, we don't have that strong attraction between the nucleus and the electron in the outermost energy level. So here we'll find, so it increases because while here in the period, while moving across in the period, okay, also related to atomic size. So as the atomic size increases, we said that, sorry, as we move in the period, the atomic size decreases. So the distance between the outermost electron and the nuclear protons in the nucleus will be shorter. So that means more attraction force, which requires more ionization energy. So as we move across the period, we find that we need more ionization energy because the attraction force between the outermost electron and the protons in the nucleus increases. So we need higher energy to overcome this kind of attraction. So like this, we could find here, as we can see, they represent element in the same period. So as we get the story that represent elements of each period, so period 2, 3, 4, 5. So we are going to find that as we move down in period 7, that means we move down in the periodic table, we have the lowest ionization energy compared to period 2. Why once compared with period 2, we find it has lower because here in period 7 we have 7 energy levels, which means the distance between the nucleus and the outermost energy level is too high or too long and less attraction force, so we don't need this high energy. So here, let's find an example. Consider two main group elements A and B. Element A has a first ionization energy of 419 kilojoule per mole. Element B has a first ionization energy of 1000 kilojoule per mole. Decide of each one more likely to be an S block and which one in B block. So here, and which one of course, or which element is more likely to form a positive ion. So simply here, they are located in the same period, but in two different groups. So as we know, once we move across the period, the ionization energy increases. So we could predict that element A, which has 419 kilojoule per mole of ionization energy, of course, this one will be in S block, while okay, the other element B will be in the B block because B has higher ionization energy than A. And as that's an S block, of course, could be a metal, and the metals easily lose electrons because it have a low ionization energy, so it means it could lose electrons easily. So in this case, it's easy to form a positive ion. So here, that's here regarding to elements or metals which they could lose electron, or that's dependent or regarding to the positive ion. What about the other case, the negative ion, the electron that gain electron? So once an atom gain electron, it will turn to a negative ion, and as it become a negative ion, it means the atom already gained some energy, and we call this okay affinity or electron affinity. So what is electron affinity? Electron affinity, it means the amount of energy or the change in energy that happens when an atom gain electron. So here we find that electron affinity, it's had the same graduation somehow like the ionization energy. So we see that electron affinity generally increases across the period because increasing the nuclear charge, okay, or that's mean as the number of protons increases, okay. So it means here the atom is strongly attract electron. That means it's easily to gain electron, okay. So like this, we find that the electron affinity increases as we move okay, across the period, okay. So here also we find that electron affiliation decreases as we move down, because as we move down, the distance between the nucleus and the outermost energy level become too longer. It means here the attraction force of the nucleus not that strong, so it will not be that able to gain more electrons. So here, like this, okay, guys, that's the properties which we're going to study today, or that's the three properties which we should know their graduation in the periodic table. Next time, inshallah, we're going to continue our lesson. Thank you and goodbye.